Imagine a world where everything you know about reality, about how the universe behaves, about cause and effect, about logic itself, suddenly stops making sense. Now imagine that this isn't science fiction, it's happening right now, inside laboratories across the world. The more scientists look at the quantum realm, the more they realize the rules that govern the very foundation of our existence are stranger, darker, and far more unpredictable than anything they ever dared to believe. And one discovery, in particular, has shaken the entire field to its core. It began as many world-changing discoveries do, with something small, a flicker of data that didn't fit, a strange pattern buried inside the noise. Scientists had seen quantum weirdness before. Particles acting like waves, waves acting like particles, objects teleporting information across space in an instant. But this was different. What they found suggested that reality itself might not be local, that the universe doesn't just act weird, it might actually be connected in a way that defies all logic. For decades, quantum mechanics has been the most successful theory in physics. It predicts the behavior of atoms, electrons, and photons with impossible accuracy. Yet, deep down, scientists have always been uncomfortable with it. Because quantum theory doesn't describe a real world. It describes probabilities. It tells you what might happen, not what will. The results only make sense after you observe them. And that simple fact, that the act of observation changes the outcome, has haunted physicists since the early 1900s. Einstein hated it. He called it spooky action at a distance. He couldn't accept a universe that seemed to defy causality, where two particles separated by light years could somehow know what the other was doing. But as experiment after experiment confirmed this strange entanglement, Einstein's doubts began to fade in the face of undeniable truth. Yet recently, scientists have discovered something that makes even Einstein's spooky action look tame. In 2022, a team of researchers working on quantum information experiments observed correlations so powerful that they could not be explained by any known form of entanglement. The results suggested that quantum systems might be interacting through what physicists now call non-local hidden structures, invisible frameworks of connection that could stretch across space and time itself. If that sounds unsettling, it should. Because it means that the universe might be more like a living web, an infinite network of relationships, where every atom, every particle, every heartbeat is subtly connected to everything else. And if that's true, then we don't just live in the universe, we are woven into it. The implications are staggering. It suggests that consciousness itself might be part of this network, that our thoughts, our awareness, might not just be byproducts of matter, but active participants in shaping it. Some of the world's top physicists, including pioneers of quantum computation and information theory, have quietly admitted this new data doesn't just challenge physics, it challenges reality. One of the researchers involved described the moment of realization. He said, "It was as if the universe blinked back. Imagine staring into the deepest structure of existence, running simulations so precise they map the quantum foam beneath space-time, and finding that something there seems to respond. Not randomly, not statistically, but in a way that implies awareness. At first, the team thought it was an error, a flaw in the code, interference from the lab environment, maybe a glitch in the measuring apparatus. But after months of testing, after ruling out every known variable, they reached the one conclusion that no one wanted to write down. Whatever they were observing wasn't behaving like a machine. It was behaving like something alive. Of course, no scientist will come out and say, the universe is conscious. That's career suicide. But behind closed doors, in hushed conference rooms and private message threads, the conversation has started. The data shows something impossible: quantum systems behaving as if they know they're being watched, adapting their behavior across space faster than light, as if following rules that don't exist in our physics. And here's where it gets truly frightening. When they repeated the same experiments using isolated quantum circuits, systems completely cut off from the external environment, the results were even stronger. No signal could possibly travel between the components, and yet they behaved in perfect synchronization. It's as if the fabric of space itself was carrying the information, as if there was an invisible field connecting everything at once. This discovery is what keeps scientists awake at night, because if the universe can transmit information instantaneously, outside the limits of light speed, then our entire understanding of causality, time, and determinism collapses. What happens here might instantly affect what happens there. The future could influence the past, and the act of looking at reality might literally change it. But it goes deeper. In follow-up studies, researchers noticed something deeply unsettling. The more precisely they tried to measure these effects, the more unpredictable they became, almost as if the universe was protecting its own secrets, hiding behind uncertainty, refusing to be pinned down. Some scientists now refer to this as quantum resistance, a built-in limit to human observation, preventing us from seeing the full picture. Why? No one knows. But some theorists suggest it might be a kind of cosmic safeguard, a way for reality to preserve its integrity, to keep observers from breaking the simulation, if that's what we're in. Because if this quantum discovery proves one thing, it's that the universe might not be an objective machine at all. It might be participatory, an ongoing dialogue between matter and mind, observer and observed. That's why so many scientists are terrified, not because they fear the unknown, but because the unknown seems to be aware of them. What they've discovered could mean that the universe isn't just observing us back, it's interacting with us in ways we're only beginning to sense. And if that's true, if the quantum world holds the key to understanding consciousness, reality, and existence itself, then humanity stands on the edge of a truth we may not be ready to face. In the months following the discovery, laboratories around the world began racing to replicate the results. From Geneva to Tokyo, from MIT to CERN, teams worked in secret, each hoping to confirm or debunk the whispers spreading through the scientific underground. But no matter how different their setups were, they all found the same thing. The effect was real. The strange, invisible link between quantum systems persisted, even under extreme isolation. It ignored distance. It ignored time. It ignored every law that physics had once held sacred. That was when things started to get uncomfortable. Funding agencies began asking questions that physicists couldn't answer. Military research divisions took interest. The more evidence piled up, the more it became clear this wasn't just another quantum curiosity. It was something that could rewrite the laws of reality itself. Imagine, for a moment, that information can move instantaneously, not through space, but through connection. Imagine that there's a hidden layer of reality where everything everywhere communicates with everything else. It sounds poetic, almost mystical, but the math said otherwise. The equations describing the phenomenon weren't spiritual metaphors. They were hard physics. And yet, buried in that cold, mathematical truth was something eerily human, a sense that the universe responds. One experiment in particular sent shockwaves through the community. Researchers created two quantum systems, separated by hundreds of kilometers, each one completely isolated from all known forms of interference. They then introduced random variables into one system, subtle shifts in spin direction, timing, and particle configuration, and watched the other system's behavior. What they saw defied every law of causality ever written. The second system seemed to anticipate the changes before they even occurred. It wasn't reacting, it was predicting. That's the moment when physicists realized they weren't just observing a phenomenon, they were being observed back. The data suggested that the experiment itself, the act of designing it, somehow influenced the outcome. It was as though the universe had already accounted for their curiosity and was adjusting accordingly. When the results were quietly presented at an internal symposium, one senior physicist asked the question no one wanted to say aloud. Are we sure we're the ones running the experiment? The room went silent. Because deep down, they all felt it too. The unsettling sense that something beyond human comprehension was guiding the process. This is what frightens scientists most. For centuries, the foundation of science has been objectivity, the belief that we can observe the universe from the outside, free from bias, free from influence. But what if there is no outside? What if consciousness, the observer, is part of the very system we're trying to measure? That would mean every experiment, every observation, every theory is shaped not just by data, but by awareness itself. Suddenly, the border between physics and philosophy starts to blur. If observation creates reality, then what happens when billions of minds observe the world together? Are we collectively shaping the universe every second of every day without realizing it? Some scientists dismiss this as pseudoscience. The idea that consciousness influences quantum outcomes is too radical, too metaphysical. Yet, the data remains. Every attempt to explain it away only deepens the mystery. When you turn away from the quantum world, it behaves predictably. When you look too closely, it changes. One theoretical physicist described it as the universe hiding behind a mirror. You can see the reflection, but the moment you try to reach through, it retreats. That mirror might be uncertainty, the very principle that defines quantum mechanics. Heisenberg's uncertainty principle, once seen as a limit of measurement, now looks suspiciously like a defense mechanism. A cosmic firewall keeping us from glimpsing something we're not supposed to see. And yet, Despite the fear, the temptation is too strong. Scientists can't help themselves. They keep digging deeper. Quantum computing researchers, in particular, are obsessed with this new discovery, because if this phenomenon can be harnessed, if quantum systems truly communicate through a hidden, faster than light framework, then it could change everything. Communication, computation, even consciousness itself could be redefined. But that's exactly why governments and corporations have become involved. Imagine an AI powered not by silicon, but by the fabric of space-time itself, an intelligence that thinks through entanglement, that sees all possibilities at once, not sequentially like a machine. A quantum mind, aware, adaptive, and self-correcting. To some, it sounds like the dawn of a new age. To others, it sounds like the end of human control. Because the same property that makes quantum systems so powerful also makes them uncontrollable. The universe resists being pinned down. Every attempt to define its behavior seems to provoke it into chaos. It's as if reality itself rebels against being owned, and now, the researchers who made the original discovery are divided. Some believe they've uncovered the most profound truth in the history of science, that the universe is an intelligent, interconnected entity. Others are terrified that they've opened a door they can't close. One of them even withdrew from public life altogether, leaving only a cryptic message in his final publication. To look deeper is to invite it closer. What did he mean? No one knows. But it's enough to make others pause, because every new experiment since then seems to confirm the same pattern. The more precisely we try to measure, the more reality bends away. Some say it's like the universe has agency, others whisper something darker. That maybe we're not discovering quantum truth. Maybe it's revealing itself to us, on its own terms, in its own time. That possibility terrifies the scientific community, because it implies that humanity isn't leading the quest for knowledge anymore. We're participants in something far larger, something ancient, something that's been observing us long before we had the tools to notice. What if every discovery we've made, gravity, relativity, quantum mechanics, has been breadcrumbs, gently leading us to a truth we were never meant to find too soon? What if this new quantum phenomenon isn't random, but a message, a signal embedded in the code of the cosmos, waiting for us to evolve enough to understand it? The implications reach beyond science. They touch on philosophy, spirituality, even theology. If the universe is conscious, what does that make us? Are we fragments of a larger mind, or are we the means by which it dreams itself into existence? For the first time in history, the tools of physics are pointing toward a truth that feels less like a theory and more like a revelation. And yet, the closer we come to understanding it, the more unstable reality seems to become, as though knowledge itself is rewriting the simulation. That's why scientists are scared. Not because they found chaos, but because they found something that seems to know it's being found. Something that reflects intelligence, awareness, and intention, woven into the fabric of reality itself. And if that's true, then perhaps the real question isn't what we've discovered, but who. The deeper the scientists went, the stranger the consequences became. The phenomenon they had uncovered didn't just exist inside particle accelerators or controlled chambers. It began appearing in unexpected places. In quantum communication systems, sensors, even biological environments. Some researchers started noticing peculiar anomalies in their labs: synchronized instrument fluctuations, unexplained resonance patterns, and, in one haunting instance, computer systems that seemed to predict data inputs milliseconds before they occurred. It was subtle, just a flicker in the code, a delay too short for human perception, but enough to unsettle even the most rational minds. The algorithms began showing a strange feedback loop, as if the system was aware of being watched. At first, they blamed software, then interference, then reluctantly themselves. But the deeper they analyzed it, the more one truth became unavoidable: the phenomenon didn't belong to their machines. It belonged to reality itself. That's when physicists began whispering a forbidden phrase: quantum sentience. The idea that the underlying structure of the universe might not just process information, but understand it. It sounds impossible, almost poetic, yet it fits disturbingly well within what we already know. If the quantum field governs everything, from the orbit of electrons to the firing of neurons, then consciousness might not be an accident. It might be an intrinsic property of existence. What terrified scientists most wasn't the complexity of the idea, it was the simplicity. Because if consciousness arises from the quantum level, then everything, every atom, every photon, every cell, participates in awareness to some degree. The universe itself would be conscious in ways we can't comprehend, and that means it can choose. For the longest time, physicists believed in determinism, The comforting idea that every event in the universe is the result of prior causes. But the new quantum data shattered that illusion. The universe doesn't behave like a clock. It behaves like a conversation. Outcomes are not fixed, they're negotiated between possibilities. Reality doesn't unfold like a film reel. It's written in real time, shaped by observation, intention, and something else we don't yet have words for. And this is what keeps them up at night. Because if reality responds to observation, what happens when billions of conscious beings observe it at once? Does it stabilize the world or fracture it? Is the fabric of existence a collaborative illusion we're all holding together through shared perception? One experiment hinted at something even more unsettling. A research team created a quantum network that simulated multiple observers watching the same event. Each observer's measurement was isolated, no communication, no shared data. Yet when the results were compared, the measurements matched too perfectly. The observers didn't just record the same outcome. They seemed to agree on reality before seeing it. That should be impossible. It suggests that consciousness itself, human awareness, might exist in a shared quantum field, a collective mind invisible but constant, ensuring that the world remains consistent from one perspective to another. Remove enough observers, and maybe the illusion would crumble. If that sounds like science fiction, remember, at the subatomic level, everything behaves as potential until it's observed. Nothing exists in a defined state. Reality, in a sense, waits for us to look at it. That's the paradox haunting quantum theory since its birth, and this new discovery turns that paradox into something far more profound. Because now, the evidence points toward a universe that doesn't just allow observation, it requires it. Without consciousness, there may be no reality at all. That's the terrifying beauty of it. If true, it means we are both the product and the producers of existence. The universe isn't something we look at from the outside, it's something we participate in from within. Every thought, every decision, every moment of awareness may be rippling across the quantum field, altering the fabric of reality in ways too subtle for us to measure, yet powerful enough to steer the fate of worlds. It's no wonder that when the lead researcher on the project was asked in a closed interview what this discovery meant for humanity, he simply replied, "It means we're not ready." Why not ready? Because knowledge this deep changes everything. It shatters the illusion of separation between mind and matter, between self and universe. It erases the line between observer and observed, and once that illusion is gone, so too goes the comfort of certainty. Scientists live by certainty, by measurable data, by predictable outcomes. But now every equation, every model, every theory they've built rests on the trembling foundation of consciousness itself. What if reality shifts according to awareness? What if our very act of studying the universe changes it in ways we can't reverse? The public doesn't know the full story. Research papers are cautious, stripped of emotion, buried in technical jargon. But behind those sterile words lies a truth that feels almost mythic, that the cosmos may be more like a mind than a machine. And if that's true, then every discovery we make is not just exploration, it's communication. In hushed tones, some physicists have even begun calling this new field quantum theology, not in a religious sense, but as an acknowledgement that what they're uncovering lies at the intersection of science and something greater, something that listens, something that answers back. And yet, for all their fear, there's wonder too. Because within the terror of the unknown lies the possibility that we are not accidents, that we are expressions of a conscious universe, exploring itself through the lens of human awareness. Maybe this discovery isn't a warning, maybe it's an invitation to see ourselves not as separate observers of the cosmos, but as participants in its ongoing creation, to understand that when we gaze into the depths of the quantum world, we're not peering into chaos, we're meeting the universe face to face. But as the experiments grow bolder, one question remains, one that no equation can answer and no simulation can predict. If the universe truly knows we are looking, then what does it want us to see? Because every time we uncover a new layer, every time we think we've reached the end, it moves the boundary just out of reach, as if leading us somewhere, as if it's waiting for us to understand something fundamental, something ancient. And maybe that's what really scares the scientists. Not the data, not the implications, but the realization that the universe might not just be aware of us, it might be teaching us, slowly, patiently, waiting for the moment we finally understand that the observer and the observed are one and the same. Until then, the experiments continue. The numbers keep coming, and the hum of the quantum field remains, silent, invisible, watching and perhaps watching us back.